Well, welcome to Alfalfa Livestream series sponsored by Alforex Seeds. I'm your host, Corey Geiger, editor of Forage Dairyman and a member of the editorial team that also publishes the Hay and Forage Grower magazine. We are broadcasting from our cheese cave, our downtown studio in Fort Atkinson at the historic W.D. Hoard & Sons Company building commissioned by Wisconsin Governor W.D. Hoard, who was also a pioneer in alfalfa, and he's the main reason it's the main reason the Hoard's Dairyman Farm is on the Register of Historic Places placed there by the U.S. Department of Interior. I look forward to serving as your host for this monthly 4-part webcast sponsored by Alforex Seeds. Today's presentation will be on how to maximize alfalfa yield. All of our presenters will be welcoming questions from our viewers during the final 15 minutes of our hour-long webcast. To ask a question, use the GoToMeeting platform and type in a question into the panel. I would first like to welcome Ron Cornish, General Manager of Alforex Seeds. Alforex Seeds and their partners provide ruminant animal producers and commercial hay growers with agronomic support, education, and alfalfa varieties for all of today's alfalfa growers. Thanks for joining us, Ron.
Hey, thanks, Corey. I'd like to take this opportunity to welcome everybody to Alfalfa Livestream, the webinar series sponsored by Alforex Seeds. This is our third webinar of Alfalfa Livestream and a series of 4. Today, our panelists again are going to be talking about how to maximize alfalfa yield. And as we talk with our customers, yield generally ranks right up there at the top along with quality. We hope that you'll find the information in this webinar useful and informative, and that you'll be able to take it back either to your own farm or to your customer's farm to improve the yield and to make variety selections and decisions for this year. We're very proud here at Alforex to have a network of over 300 dealers and distributors across the U.S. representing the Alforex Seeds brand. And we realize that there are a lot of choices when it comes to purchasing alfalfa seed. We feel with Alforex Seeds' focus on alfalfa and other forages, we break out from most of them. And we pride ourselves on varieties development with our connection back to Corteva Agriscience, our parent company, who has one of the world's largest alfalfa breeding programs. So again, thanks for joining. I hope you find the webinar very useful and informative, and I'm going to turn it back to Corey.
Well, thank you so much, Ron. I really appreciate you joining us again for this Alfalfa live stream. To get us off and rolling on the topic, how to maximize alfalfa yield, we're going to start out with a poll question. The poll question reads like this. What management decision have you used to increase alfalfa yield? Go ahead and select one: variety selection, cutting interval, pest resistance, or timing of cutting. So go ahead and enter your answer here. And we got a strong leader on the board, so this will be interesting. We'll wait till we get a good majority of everybody voting here, and then we will cut the poll off. And with that, I will ask our first presenter to go ahead and turn his webcam on as well. So let's go ahead and cut the poll off and see the results there. And our viewers can see the results. And I know our next guest will provide a great deal of insight on maximizing alfalfa yield. I'd like to welcome our next presenter, Dr. Don Miller. Don is currently Director of Product Development for Alforex Seeds and is based out of Napa, Idaho. Don, I look forward to hearing your thoughts on how to maximize alfalfa yield and any comments you might have on the results of the poll. You remember variety selection came in at 67% and timing of cutting was at 22%. Don?
Well, I think that was pretty interesting. You know, as an alfalfa breeder, it's pretty encouraging that people are looking at the variety as a means of increasing alfalfa yield. So what I hope to do in my part of the presentation today is to give you a few ideas on how to maximize your alfalfa yield and also how to maintain it or protect that yield from pests that are out there in the field or the things that might detract from yield. So like we just said, you know, picking the best variety with the the best yield potential is probably the thing that will help you maximize alfalfa yield more than anything else. So variety selection, make sure you pick a variety that's adapted to your region, the appropriate fall dormancy, and also in areas where you have severe winters, make sure you have a winter survival rating that will allow that alfalfa to survive the winter. And when you select a high yielding variety based on the university and company yield data, you know, find out what are the best varieties that are yielding the most in your area. Now, when we talk about alfalfa yield, you know, each alfalfa variety has a potential genetic yield, but there are things out there that can detract from that yield. If we have a disease, say like phytophtha or root rot, your potential yield might be reduced by a half or a quarter of a ton. So selecting a variety that has adequate resistance to whatever diseases or pests or nematodes that are occurring in your area can protect that yield that you could get off that variety that you bought. So yield minus pest damage is actual yield. So again, having a good disease and pest resistance can make a difference. Now here's a good example of what I'm saying as far as variety selection and how we've improved over time. You can see here in the center a vernal that was released in 1954, and we've come a long ways since then in improving the disease, insect resistance, and also the potential of varieties. You can see on the right here, a variety was released in 2003, sure enough better than vernal, and then the one on the left, 2006, sure enough, we're pushing the envelope, getting better and better yields all the time and improving those varieties. Another thing you can do to try to improve yield is consider using a higher alfalfa yield. Consider using a higher fall dormancy variety to increase the potential yield. You know, 3 years we've been seeing a push to maybe try some of these higher dormancy alfalfa varieties as a means of increasing yield. But with that, we need to make sure that we actually have adequate winter survival resistance in those varieties to protect those varieties from any winter severity conditions that might damage those. So as we move from a fall dormancy 4 to a fall dormancy 5, make sure that you have selected a variety with adequate winter survival resistance, at least below 2.3 and in that 2 or lower range. There we go. Okay, another thing that we can look at, there are alfalfa varieties that are bred with a major emphasis on yield. We have in our product lineup what we call high ton varieties. These are the real racehorses of alfalfa yield. They're out there, they recover very fast, 3 to 5 days faster per cut than what you're used to, fast recovery rate, high yield potential. This is what I'm talking about as far as that fast regrowth. Most alfalfa varieties grow at a 1.5 to 1.7 centimeters of growth per day. But with the high ton varieties, we've actually selected parent material that grows at a faster rate. You can see AFX 429, 1.9 centimeters per day, and then AFX 579, 2.26 centimeters per day. Well, what that does is give you a fast regrowth, and you're gaining 2 to 3 days on every cut. So depending on your growing season, you have the potential of gaining an additional cut by saving 2 to 3 days on every cut. Now with that, each of those varieties are going to hit maturity a little bit faster, and so you need to make sure that you harvest them accordingly and get those varieties out of the field at the proper cutting time. So they'll mature 2 to 3 days earlier than what you're used to with the old varieties. Here's an example of that yield potential of these high ton varieties of Washington State University alfalfa yield trials. You can see AFX 469 had 33.6 tons and versus the mean of the trial. That difference, that yield advantage of 2.8 tons per acre. Well, if you put $150 a ton against that 2.8 tons of increased yield, that's $420 per acre more profit that could go to your bottom line. So again, there are varieties out there that have been bred for increased yield that have really some significant potential. Now, depending on where you are in the country, there are areas where salinity is a factor and can affect alfalfa yield. So there are varieties like in our lineup, high salt varieties that have been bred for resistance to salinity. You can see here in this photograph that this variety didn't have adequate salt tolerance, and there's hot spots out in that field where the alfalfa seed didn't germinate. But even in the other parts of the field where it did germinate, salinity can be affecting yield. And if we have a EC above 2, where each point above 2, we're losing 7.5% yield. So there are varieties, if salinity is a factor, that can improve yields in those conditions. Now, the other thing that can affect yield is traffic, wheel traffic out in those fields. We know that during the course of a season, 40 to 70% of an alfalfa field is run over by traffic. And in those rows where the wheels are running over the plants, we're getting 16 to 26% yield loss in those traffic areas. So being aware of how much traffic you're going across that alfalfa field, when traffic occurs, makes a big difference. So when you're driving across those fields, it makes a big difference on the damage that you're doing. If the new regrowth stems are broken by traffic, the plant growth must start over, and that depletes the root reserves. Here's some data that came out of Wisconsin. You can see in that green bar, there's no traffic damage, year 1, year 2. But if you run across that alfalfa 2 days after that initial cutting, you do get a yield reduction. But sure enough, at 5 days, that orange bar there, we can see that can have a significant reduction in yield. So when you run across those fields, makes a difference. So once you cut that alfalfa, try to get that alfalfa out of the field as soon as possible, and not linger, because the longer you're out there running over that regrowth, the more damage you have. So yield loss to the next cutting is greater if the traffic occurs later after mowing. Dr. Understander did some work a few years ago, and he said the yield loss is generally 4 to 6% per day after mowing. So if you run across that field 5 days after initial cutting, you have a potential yield loss of 22%. Now, in recent years, we've been seeing an improvement in forage quality of alfalfa varieties, and so with that, we've improved that harvest window, and we're seeing that you can extend the harvest interval to obtain more yield. So more time in between cuts, allowing that plant to grow a little bit longer. And so if you can extend the cutting interval for yield and still maintain forage quality. So there are genetics out there that that forage quality is improved. So with extended harvest, you have also additional benefits. Since the plants are allowed to grow a little bit longer, with that longer cutting schedule, you have improved root reserves, and at the end of the day, less plant stress, which eventually relates to better yield. But there are some potential pitfalls with that extended harvest. If you extend the harvest too long, you have some things that can start occurring. So if you go from 35 days to 40 plus days, maybe a weather event happened, whatever, you can get lodging. You may have an increase in leaf diseases, and also you may be running over that alfalfa out in the field, or you're cutting that next cut prematurely. What I mean by cutting that next cut is that at 28 days, you can see here on the left, the alfalfa top growth is just starting to bloom. But if we allow it to go to 35 days, the plant thinks it's really finished with that first that growth, and it's going to start sending up new shoots from the bottom, from the crown. And so if you go all the way out to 35 days, there's a lot of new shoots that are emerging out of that crown, and you have to really be careful not to cut those off, because that's the next cut coming along. So if you do, be aware that that new regrowth is coming up, and you might have to raise your cutter bar and not cut off that new emerging growth. So again, be aware if that extended harvest goes too long, raise your cutting bar and don't cut off that new growth that's coming up from the bottom.
Thanks, Don. As a reminder to our viewers, as you hear from our panelists today, please submit your questions into the GoToWebinar question panel. And we're getting a number of questions in already. We're going to go straight to another poll question before we hear from our next speaker. The poll question will read like this. When is the most challenging time for alfalfa to access nutrients? A, first cutting, B, second cutting, C, third cutting, or D, simply doesn't matter. So go ahead and answer that poll question there, and we'll wait for a number of you to do that. And we'll invite our next presenter, Steve Norberg, to go ahead and turn his webcam on so he's all ready to roll here. So let's go ahead and cut that poll off. And the answer that the viewers selected is 41%. And I know our next guest will provide a great deal of insight into all the measures in that poll. Steve Norberg is a member of the Washington State University agricultural team, where he serves as a regional specialist for Adams, Benton, Franklin, and Grant counties. In that role, Steve provides the Columbia Basin producers with guidance on issues related to forage and irrigated cropping systems. Steve, I look forward to hearing your thoughts on using hay quality testing samples to improve alfalfa fertilizer recommendations. Welcome, Steve.
Thank you. I want to just say thank you. I enjoy being a part of this. Again, we're going to talk about using hay quality testing samples to improve alfalfa fertilizer recommendations. And I want to thank my co-authors, Don Llewellyn, Steve Franson, Joe Harrison, Aaron Mackey, and Liz Whitefield. And I especially want to thank the Alfalfa Checkoff Program through National Alfalfa and Forage Alliance, otherwise known as NAFA, as they provided the finances to do the research that we're going to talk about today. So here's a picture of this 3-year experiment. This picture was taken, it was a spring planting the first year. And as the spring planting went through the winter and come back into the second year in this low phosphorus testing soil, you can see here it was at 5 parts per million P in the Olsen P method. As you can see right there in the center, the regrowth is slow, and it did eventually regrow. But this is what phosphorus deficiency looks like in the field. And it often looks like just, slow to regrowth and uneven growth. If you look on the very left side, where we put on a 240 pounds of P2O5 per acre, you can see that the stand is very uniform and growing well. So I just wanted to give you a chance to look at what phosphorus deficiency looks like. So this is the yield results from 2018 to 2020. So you can see the first line is a blue line, and excuse me, the blue line there, you can see because it was a 3-cut system that year, the first year, the yields were about, increased from 5.5 to about 6.5 tons per acre. So we did see a yield increase, even though it was just the 3 cuttings. Then you look up at the yellow line was 2019, the second year. And you can see that we went from about 8 3/4 tons all the way up to 10.5 tons per acre. And so we did see a significant yield increase all 3 years. And so we'll talk some more about some other things on the next slide. So I know that farmers are always interested in economics, and this is a very busy slide, but I'm going to lead you through it. So we wanted to look at the economics of the fertilizer application. We use monoammonium phosphate, and the price when I went into it to start this experiment was $560 per ton in the Pacific Northwest, or basically 53 almost 54 cents per pound of P2O5. So we wanted to know if hay price was $150 or $106 or $200 a ton of alfalfa hay, what was the economics looking like after you paid for the fertilizer? And so this was basically gross return after paying for the fertilizer, and that's on the right axis, the vertical axis. And you can see the white line was what the gross return after fertilizer expense looked like at $150 per ton, and it went up and peaked, but then came back down if you over applied the fertilizer. The green line, on the other hand, shows if hay was $200 a ton, what it peaked out like. And so from this, we were able to look in this particular year that at 150 to 160 pounds of P2O5 per acre, maximize gross revenue minus fertilizer cost at $150 and $200 per ton of hay, respectively. So there was about $10 or 10 pounds per acre difference in optimization when hay price went up. So that's something to also keep in mind. So when did you get the return on your investment? And so this slide will kind of help identify this, and this really will help answer the question you had on the poll question. So this research was done in Prosser, Washington, and what we wanted to find out was of the total yield increase for each treatment, what percent of that yield increase came from what cutting? And let's just look at the 120 pound per acre rate, which is in the center of your slide there. And these are stacked bars. So each cut, you start with the first cutting, and you can see that 51% of the yield increase came from the first cutting. So the plant really responded in the first cutting. And that was really probably the answer for the poll question. As you can see, there's the second cutting, we got a 16% of the yield increase. The third, cut 3 was 12%, and cut 4 was 9%, and the fifth cut was 13%. So really the bang for your buck is early on in the season when the soils are cold, and that plant needs to have the fertilizer to grow well. So I wanted to give you a little bit of background on tissue testing. So again, we're trying to develop a system where you would use your hay quality sample, which would be in your bale in your stack, and that's a little different than sampling in the field. And what part of the plant are you getting? Of course, in the bale, you're going to get everything that you cut, and so that changes the level of phosphorus that should be in your plant to identify if you have enough phosphorus to maximize yield. So on the left side of the slide there, you can see that was the first year of this research that was conducted by Steve Orloff and Dan Putnam in California. And they looked at the whole tops of the plants, which is the blue line. They looked at the top 15 centimeters of the plant, and then the mid stems. And so they cut the plants in 3 separate portions, and then just looked at the middle of the plant. So you can see here that the ideal response is going to change depending on what part of the plant that you're harvesting and looking at. So what we're going to be looking at is the blue line for our data here, and you can see there it was almost 0.38, crossed down to 0.3, depending on the time of maturity. So early bud, it's higher in concentration, and as the plant matures, the percent concentration drops. And you can see this trend's also followed in the second year, which is in slide B on the right side. So again, that's something to keep in mind. The timing of the sampling and the plant part you're going to be sampling affects the results that you're going to get. So let's look at what we received in this experiment. So this is looking at the 2019 whole plant phosphorus concentration at harvest by cutting and by rate. So as on the horizontal axis, you see the cutting number. So we had 5 cuts. And on the vertical axis, we got the percent phosphorus concentration that we received. Now, as you can see here, there was a large variation in the first cutting. Again, the plants really did respond to that phosphorus fertilization in the first cutting. And so it ranged from all the way from 0.2 all the way up to 0.43. And so all in the first cutting. You can see the other trends that we're seeing here is that in the second was where we received the highest level of phosphorus in the plant. And this seems to be consistent with between years, and even in another experiment where I did a fall application, that the second cutting is where the highest concentrations are in the plant. And then it tends to drop off depending on which application rate that we used. Now the two blue lines there, you can see were actually the optimum for that particular year. And so the optimum, the dark blue is for $150 a ton. The lighter blue is for $200 a ton. And you can see them paralleling each other, and it ranged from 0.34 in the first cutting to as high as 0.4 in the second cutting, and then drops off. So just something to keep in mind, that this does vary a little bit based on which cutting that you're looking at. And again, the second cutting is going to be the highest, and the first cutting is going to be where you're getting the biggest bang for your buck. So now let's look average phosphorus content averaged over cuttings over the 3 years. And you can see there's a different line. And as the two vertical lines are right around 160 is where the ideal optimum fertilizer rate was. Excuse me. Next slide, please. Okay, so now I'm going to show you a little bit how much the misapplication of phosphorus can cost you in the field. So on the first column, you'll see the hay phosphorus content, and it ranges from 0.24 to 0.38. And if you look at the far right side, it's probably the easiest one to follow. Over 3 years, how much did it cost if you maintained that 0.24 all 3 years? And so $522 per acre if you had that low of phosphorus content in your hay. At 0.36, which was the optimum, for the $200 per ton hay, and virtually for the $150 ton hay as well, you can see that, you know, how much you're going to lose really varies depending on the hay content that you have in your harvested hay. You can overapply it at 0.38 and lose money as well. And so this kind of tells you how much you need to decrease in your application based on your hay content at that you have. Now, when you're going to measure your phosphorus content in your hay, sometimes you get a phosphorus content in your NIR sampling, and it'll come back. Now, that's not quite what you can get with an ICP, but it will give you something in the ballpark. So ideally, what would happen was that you would split the sample at the lab. So have the lab do it. First, they have them grind it, and then separate out one sample to do an ICP and one sample to do the NIR. And so that the best way to split that, if you split it before you when you send it in and before it's ground, you probably won't get an even amount of mixture of the hay, of the leaves and stems. And so it pays to have the lab do the grinding and separating there. So let's look and see how the soil test changed the P levels using the Olson P method, and also how much was totally removed from 2017 to 2019. And so here you look at the P205 rate applied. We went from 0, 30, 60, 120, and 240. But let's look at the red line there. So let's say you put on 120 pounds. If you look at that, that was applied per year. And so really the total would be 360 pounds that you applied. And you removed a little bit more than that, 382 pounds at P205. And as you look at here, the first soil test started at 7.6, very low. The second soil test the following year was 7.8, so we increased a little bit. And now remember, that was the 3 cuttings, so we didn't pull off as much hay and as much phosphorus because it was only 3 cuts. And you look at the soil test in 2019 where we took 5 cuts. We actually had a drop and another drop in 2020. And so we're taking off more than what we're putting on. And so just be aware that the more tons that you pull off that field, the more phosphorus you're going to be removing. And also depends on the phosphorus content as well. So let's switch and talk about a little bit about potassium. So this is what a leaflet that looks like that has potassium deficient. You can see the chlorosis coming in from the outside edges, almost to the midrib. It'll give the field kind of a yellowish haze from a distance. So let's look at 2018 through 2020 as we increased the potassium from 0 to 320 pounds. You can see here that the first year when we had the 3 cuts, we did not see a yield response. However, the following 2 years, we got significant yield response. So in 2019, the yellow line, we went from about 9 1/4 tons per acre all the way up to about 10 1/4 tons per acre. So we gained about a ton. And same the following year in 2020, from 10 1/2 to almost 11 tons per acre. Actually, it was 10 1/2 to 12 tons per acre. So let's look at this and look at by cutting. Where did we see our response again? Again, let's assume that you put on 160 pounds to the acre. And so you can see that 61% of the response was taken of the total yield response that you got to your fertilizer that you put on an early spraying was in the first cutting. 32% was in the second cutting. And you can see you only got a little bits in the 3rd, 4th, and 5th cuts. So again, a fall application or early spring, so that fertilizer will be there for the plant to take up. Okay, so how much potassium K2O are we hauling off our fields? This is what's a little bit scary. So at the 320 pounds per acre rate, probably higher than most producers are putting on, probably virtually all of them. You can see here in 2018, even in 3 cuts, we pulled off 300 pounds per acre. In the 2019, where we had 5 cuts, we pulled off 616 pounds of K2O per acre. So we're mining that field significantly. In 2020, we had the potassium content dropped significantly in this soil and dropped all the way down to 250 pounds per acre. But look at what happened in our drop in our potassium test. This was ammonium acetate test, and you can see that we dropped started off at about 100 parts per million test, and then at the end of the experiment, it dropped 31 parts per million in the first foot, 31 parts per million between the first and the second foot, and then between the second and third foot, we also lost 36 parts per million. So that's soils mining that potassium all the way down to 3 feet significantly, and we're pulling off, you know, a lot more than what we are putting on there. So just something to be aware of.
Steve, thank you. We're going to do a quick question here, and we got a great audience interaction here. So real quickly, I'm going to reference the slide, percent increase in yield over the control as influenced by cutting and phosphorus rate. And the question, Steve, is when you were discussing that graph on phosphorus application, was the fertilizer applied before first cutting or after first and third cutting? Real quickly.
No, the fertilizer was put on before the first cutting, and so it was actually early spring. So it was put on in March. Late March was when the application occurred, and of course our first cutting would be about mid-May.
Thank you, Steve. And we'll go to our next poll question here, our final poll question today, and we'll invite Glenn to turn on his video camera. The question is, what type of irrigation method do you use to water your alfalfa? A, pivot, B, wheel line, C, drip, D, flood, or E, Mother Nature, as in waiting for rainfall. So go ahead and answer those poll questions here. And we're getting two strong answers here. Let's go ahead, and actually we're well over 2/3 filled out here. So let's go ahead and cut that poll off. And we'll see that the pivot is a strong answer, and certainly Mother Nature. Let's talk water and alfalfa. Glenn Shewmaker, welcome to Alfalfa Livestream. Glenn is Professor Emeritus and former Extension Forage Specialist with the University of Idaho, located at the Kimberly Research and Extension Center. Raised on an irrigated row crop and forage farm near Kimberly, Idaho, Glenn is still involved with the family's farm producing alfalfa hay and other forages. Forages support the farm's beef cow and calf operation on irrigated pasture in both in southern Idaho and rangeland in northeastern Nevada. Glenn, I look forward to learning more about water use and irrigation of it in alfalfa. Glenn?
Thanks, Corey, and I appreciate the slides that Dr. Miller and Dr. Norberg have done. And I think water use goes along with those management practices where we can fine tune and optimize our alfalfa production. So I want to talk about, it's important for us to know that alfalfa has the highest seasonal water requirements of crops. But when we have water stress, we'll close the stomata. And when we do that, photosynthesis is impeded. Well, certainly drought and improper irrigation are often the limiting factor of alfalfa production. And in fact, irrigation is essential in a lot of the areas of the West. Well, this slide shows two temperature readings. They're on the same field, just a slightly different location. And the key to using water, to optimize water use, is to try to get the water transpiring through the plant, not just evaporating from the soil surface. So on the left there, you can see the soil temperature is 100 degrees Fahrenheit. On the right, the alfalfa canopy temperature is 63 degrees Fahrenheit. This is the same time, same place. The reason the alfalfa canopy is cooler, water is evaporating, mostly from the stomates, and that cools the plant. But it also allows CO2 to enter the plant and be used for photosynthesis. Well, we have an alfalfa factory, and the drivers for that are sunshine and water. And the need to define a term, evapotranspiration, or you'll see it ET. Evaporation is the water that's evaporated from the soil surface, or it could be the leaf surface also. Transpiration, however, is water evaporated from plant tissue. So it's actually evaporated in the stoma and then comes out of the plant. Well, the ET for alfalfa hay varies, of course, but it averages about 36 inches per year, or 3 acre-feet per year, 900 millimeters in Idaho. So water deficiency causes a plant's stomata to close in order to conserve water. Alfalfa evolved in Iran, Afghanistan, in that arid environment. And so it has evolved to limit water use when it gets excessive. And so we have pictures of stomata there on the right. And if there's adequate water, those cells are rigid and there's an opening there. And when there's water stress, those cells collapse and there's very little opening. So again, that restricts carbon dioxide availability, which fuels photosynthesis. So growth will stop. So water use efficiency is going to be highest when the water supplied to plants by either irrigation, precipitation, or groundwater approximates the evapotranspiration. Now, variety, as Dr. Miller explained, within fall dormancy rating and regrowth ability has little or no effect on yield for a given amount of water. There's a lot of other things involved, and certainly having a fast regrowth will recover that. So this graph just shows 2 years of evaporation or evapotranspiration curves, happens to be at the Kimberly location. But I want to make a couple of points with this. There's daily variation. As you can see, it varies widely. But the important point of this is if you look from the 1st of April up to, about the end of May. And if you look at the dashed lines on the top, there's a low pressure, that's a low pressure pivot system. The high pressure line would be an older high pressure system with lower capacity. That high pressure system's putting on about 1/4 of an inch per day of irrigation water. Well, after the end of May through clear until late August, the ET is greater than amount you can apply with either a high pressure and then a little bit later the low pressure systems. So the important point here is if you have irrigation capability, or even if you have just rainfall, the only time you're going to get a good deep soil moisture in the soil bank is in the spring or carried over from the fall, but not much of that happens. So that springtime is a critical point. Well, this shows a simplified curve for water use in alfalfa season long, and this shows the effects of cutting. And you can see the steep incline in ET from April to May. The crop is cut then, and we can see the number 4 there. That's the inches of water required per ton of hay. And if we go to the second cut, we can see a very rapid increase in water use, up to about 3/10 per day. And then again, a second cutting, and we can see that the inches, it was 5.5 inches per ton of hay of water use. And then for third cutting, 7 inches per ton of hay, a fourth cutting, 6 inches, and then a final cutting, 4 inches. So certainly evapotranspiration varies with the environment. So this chart shows the average daily pan evaporation in millimeters. And then we have the months along the x-axis. And we have several locations graphed here. So the highest daily pan evaporation, which is used to predict ET, and almost all weather stations have this information available. But you can see that Grand Junction, Colorado, and Fresno, California can use from 8 beginning in May up over 10 millimeters per day. And then it drops off in August, September, and October. Well, Yakima, Washington is the green line, so it's in the middle, and it peaks in July. Marshfield, Wisconsin, it's consistently below 6 millimeters per day, so much higher relative humidity, in some cases a lot of clouds, little less solar radiation, so the water use there is actually much lower. Next. Well, you can find what your mean annual pan evaporation is from this map. And if you just kind of look over to the between the lines of where central Minnesota and Wisconsin is, you can see it's between 30 and 40 inches of annual precipitation. If you're down in South Dakota or eastern Nebraska, you're from 50 to 60. And if you go down into the panhandle of Texas, you're up 90 to 100. So great differences in that pan evaporation. And we can use crop coefficients to estimate ET. And for example, about 7/10 is a good coefficient season long for alfalfa. So this graph shows the effect of soil water content and soil texture. So in the yellow colored area, that's below the wilting point curve, and that soil water is not available for plant use. So that's least in the sand or sandy loam, it's the most in a clay. Clay will hold a lot of water, but it holds that very tightly. So the next category we have is available soil water, and that includes the purple and the light blue colors. So the purple color is the yield limited. The yield will be limited by plant water stress. And then we can go above that and we have readily available soil water. And that is the area below the field capacity curve. So what we would want to do is to try to keep it in that lighter blue area if we can. So how much available water do we have in soil? Well, let's assume that our effective rooting depth is 2 feet. That's relatively shallow, but there are some places where you only have a foot till you get to rock or some restrictive layer. But let's assume 2 feet. Let's assume we have a silty clay loam soil that will hold 2.3 inches of water per foot. And let's also say we only want to deplete 50% of that available water, like we showed in that last slide. We want to keep it above the yield limiting part. So how many inches are available? Well, we multiply the 2 feet times 2.3 inches per foot. That gives us 4.6 inches available water. But we only want to use half of that, so we multiply it times 0.5. That gives us 2.3 inches. So knowing that, we can determine when we need to irrigate. So we have 2.3 inches of available water. Let's assume that we have 1/4 of an inch of ET per day. How many days until the next irrigation? Well, we divide the 2.3 inches by 0.25 inches per day, and that gives us 9 days interval. So that's how we calculate when to irrigate. Now, alfalfa can be very deep rooted, and that's good. It can extract water from progressively deeper depths as water stress increases. And we have on this chart water removed in inches and the depth on the y-axis there. So if you look at the first week, you can see that the majority of the water removed comes from the top 6 inches of the soil. If we go to the third week, we can see that the most water removed is down from the foot to the 1.5 foot zone. And let's go down to the 6th week. Then we're extracting it down from that 3.5 to 4.5 foot level. So that varies a lot by the amount of water and the depth of the soil, and hopefully your roots extend to all that depth. Well, when we have water stress, we have drought-induced dormancy. Alfalfa again evolved in an arid environment, and alfalfa plants have the ability to go in this drought-induced dormancy. Now, if the plant has adequate carbohydrate reserves and it doesn't get critically dry in the soil, the plant should survive until moisture is returned. But drought-stressed alfalfa will bloom right after cutting. Alfalfa is indeterminate. It tries to produce a flower under certain conditions to produce seed. And now I've had growers try to blame the variety on this, and it's not a varietal thing. It's a irrigation management thing. They were using pivot irrigation on a very sandy soil, which is a little challenging. But they never had the roots established deep enough. The roots didn't go below 6 inches. And so with the cutting interval to let it dry out for harvest, the plant went into dormancy and tried to bloom right after cutting. So this graph shows the rate of crop growth and versus the moisture content of the soil. So we can see on the lower left there the permanent wilting point and a very, very nice, fairly linear part of the curve. So the more moisture content of the soil, the higher the rate of crop growth, up till we get to an optimum growth. And you'll see that is not quite to field capacity. So at field capacity, we're actually dropping down, and that's probably an oxygen limiting factor when the soil is saturated. So that is the peak is less than field capacity. So what are the recommendations we might have? Number one, irrigate early to fill the root zone. And as Dr. Norberg said, if you have that fertilizer there, take advantage of that high growth rates and the fertilizer. So irrigate early, maximize the depth per irrigation, get those roots extended into the soil. And if you have those healthy roots deep in the soil, then they could take advantage of the soil's water holding capacity. If you have limited irrigation water, provide adequate water until the water is gone. Allow the last cutting to be mature and dry when you cut it so that the plants will go into dormancy, or don't even cut it if, in a lot of cases, our dryland producers know that number one is may not be economically harvestable, and they don't want to lose their stand. So use estimated water consumption provided by Agromat data system, and also get out your soil probe or shovel and check your soil moisture, verify that. Again, use that water when it's most efficient. That's early and late in the system. Shut off the end guns if you have those. Irrigate at night and in low wind if you can, and repair leaks and worn nozzles. Alfalfa does have some of the highest seasonal water requirements because it grows from March through October, but it does have high water use efficiency compared to corn, and it's a good drought survivor. Certainly, drought and improper irrigation limits alfalfa yields, assuming we've got good varieties and proper plant nutrition.
Well, thank you, Glenn, for your thoughtful insights. Let's welcome back Don and Steven. They can turn on their webcams. At this time, we'll be taking questions from the audience. We have over 20 questions, and I'm going to say this, that our presenters after the presentation will answer those that we don't get to today, but we're going to go straight to speed round here. And the first question, Glenn, is going to go to you. And it was the first question in, and we have viewers from across the United States and around the world. This gentleman's from Pakistan, and he has temperatures regularly from 40 to 48 degrees Celsius. That's 104 to 120 degrees Fahrenheit. Now, why we're asking that question, he's asking, what tips do you have to maintain alfalfa stand and get more production in hot conditions? Now, our growers in places like Arizona or California's Imperial Valleys face those same conditions and get sometimes 12, 13 cuttings a year. What's your recommendation for that group, Steve? Or excuse me, Glenn. Go ahead, Glenn.
Well, certainly having a fast recovery alfalfa, something that tolerates the heat and lots of water. Yeah, I don't know what else I can add other than what I said, but they successfully grow it, in Saudi Arabia. And I was there in September, and it was 110 it was, 35 degrees C. So yes, it can be done. Alfalfa is highly adaptable.
Well, thank you, Glenn. Steve, next question for you. When would be the best time to apply fertilizer to alfalfa? I was thinking of applying in fall after my final cutting, or is spring better? Steve?
I believe that either one will work. One thing that you want to definitely think about is you don't want to be in that field when it's wet, and you're going to tear up your field with your equipment. So if your springs are really wet, then I would probably do it in a fall period when you're not going to tear up the field. But I think either one of those would be optimal situations, either fall when things go dormant, or in the spring, hopefully before any growth really occurs. And so I would kind of base it on, whether you can get in the field or not.
Thank you, Steve. Don, next question's for you. What percentage of yield is leaves as opposed to stems? And they asked that question because the overall title of our presentation is how to maximize alfalfa yields. What's the ratio on weight there?
On pre-bud, it's 60% leaves, 40% stem. At 10th bloom, we're 50. At full bloom, we're 60% stems, 40% leaves. As that plant matures, ratios change.
Glenn, next question is for you. To improve yield and quality, what cutting interval do you recommend? And I'm sure that varies based on a number of factors.
Yeah, yield is certainly the longer you can go, the more yield you'll get, because you're up at the top part of that curve up until you get into starting bloom. But quality will decline. There's a lot of factors that affect that, but a longer growth period will give you more yield, certainly.
Steve, Steve, the next question. At what rate should we be aiming for phosphorus application? And that's probably a little bit more complex question because maybe based on soil test and that, but go ahead and give that one a whirl.
Well, again, I strongly recommend doing the soil testing and then using possibly the technique that I shared to tweak it. So that's really what I'm hoping that people can look at is look at your soil test and then also the tissue test that you get there and try to get to that percent phosphorus in the tissue that we desire. And so I don't want to give out a specific rate. It really depends on what's in your soil. And so soil testing is the way, and then using tissue testing to kind of hopefully monitor and see how you're doing with the plant uptake.
Don, the next question is for you. Is variety yield always determined by fast growth or fast regrowth?
No, I think it's a combination of things. Yield is dependent on a lot of different factors. One way that we have obtained more yield is that fast regrowth, but also in some of our varieties we have, they start off a little slow and then they gain as they approach maturity. So depending on the variety, there's a lot of different ways that you can obtain yield.
Glenn, we're going to send 2 water questions your way real quick here. How important is filling the water profile before first cutting with limited water? Is it better to use it all up front or try to stretch it out?
I think it's best to use it all up front as long as you're not running water off the field or too deep. It's just hard to beat that water use efficiency early or late.
Next question, Steve, does salty soil inhibit nutrient uptake?
So in your soil, the salts often can affect the pH of the soil. And so once you get your pH off of optimum, yes, it will affect your phosphorus uptake.
Don, the next question, are foliar applications as effective as soil applied?
I think it's just another way of supplementing. Sometimes like on some of your micronutrients, you can do a foliar, and that is an efficient way of doing it. But you know, having that material in the soil, that's great. But a foliar sometimes works for certain things.
Glenn, next question. We're going through these so quick. We're going to try to keep moving here. In a loamy sand soil, is it better to irrigate with a pivot running slow and less often, or fast and more often?
It's better to run it slower so you get the deeper irrigation. The faster you move a pivot around, you're wetting more soil and leaf surfaces, and you get poorer water use efficiency than getting a deep irrigation.
Don, we're going to send the next question to you. There have been discussions about increasing yield with varieties. Is there any other recommendation on increasing yields on existing stands that are high quality, but not necessarily high yielding?
You know, we always want to put less stress on those plants. You know, make sure you have good fertility, good management practices, and you know, your cutting interval can make a big difference. If you start cutting at very short intervals, then the next cuts are going to suffer a little bit as far as having the root reserves to put out the tonnage. So just good management, making sure that that plant has all the things it needs to produce that yield.
Glenn, another quick question here. Is it better to give 1/2 inch per acre irrigations every day, or 1.5 inches every 4 to 5 days?
Oh, that is a good question. I think it's going to depend on the soil, but I think again, any more at one time will reduce the water loss to just evaporation. So I think I'll go with keeping the area that's actually under irrigation small as possible.
Steve, we're going through real good here. Is there any benefit to cutting alfalfa at 6 inches high versus 3? And they're going back maybe to Don's picture there about that regrowth. Maybe I should kick that to Don, but Steve, go ahead and take that one.
Well, again, you know, Don was talking about, you know, trying to avoid doing any cutting of regrowth so that you don't cause a reduction in root reserves of carbohydrates. But the higher that you cut, you're also going to have an effect on the yield of that particular cutting. So, you know, again, I would go with what Don said. Hopefully, keep your harvest interval proper so that you can take, you know, cut it 2 inches or whatever, and take that. But hopefully that answers the question.
Thank you, Don. Next question, fall dormancy question. Central Michigan, would you use a 4 or 5, up to a 4 or 5, or what would you be recommendations there?
I think, you know, probably a 4, but we have been seeing, you know, in the past, if you used a 3, you might stretch it to a 4, or if you used a 4 in the past, you might stretch it to a 5. But again, that winter survival rating is really critical to give you a sort of an insurance package that you could survive the winter. So if you're trying to go to a little bit higher dormancy than what you're used to in the past, make sure that winter survival rating is around 2 or lower.
Steve, this question is yours. We're 2 questions left. In Iowa, often in spring it is very wet and we have to mow first cutting in muddy or soft fields. What causes more damage, cutting too late or cutting in a wet field?
You know, long-term damage will be cutting as too wet. You're going to compact the soil and cause more permanent problems. And so, to me, I would probably, you know, again, it depends on how wet we're talking about, and so there's a lot of variables in there. But you know, cutting too wet, I think, could cause some really serious problem term for you, and I would probably try to avoid that.
And we're going to go with the last question here that was asked before the top of the hour. Glenn, your final question. My neighbor and I have discussed our alfalfa irrigations. We have both found stressing the plant with lack of irrigation has increased quality, and over irrigation has increased yield somewhat, but lowered quality. What do you believe caused this?
So that's a good question. Actually, with a very slight water deficit, alfalfa growth will decline, but it'll be primarily stem growth. So you get a higher leaf to stem ratio with the same maturity in a slight water stress situation.
Well, thank you, Glenn. We had a few questions asked just real close here in time, so we're going to have those answered offline. And I want to remind all of our participants, you will receive, and our viewers, or participants, will receive a survey at the conclusion of this webinar. Please mark your calendar for our next presentation in the Alfalfa live stream series. It'll take place on March 18th. That's a Wednesday, 11 a.m. Central Standard Time. If you're out in West Coast there, Pacific time, that would be 9 a.m. The topic will be best management practices for alfalfa stand establishment. Our presenters will be Don Miller with Alforex Seeds, Kim Casita with Michigan State University, and Earl Creech from Utah State University. On behalf of Ron Cornish, Don Miller, Steve Norberg, and Glenn Shewmaker, thank you for joining us today on Alfalfa Livestream. I am Corey Geiger, and we wish you all a good day. Goodbye, everyone.